Today we will present our projects. The project of our team is a VR system. We will build driving simulators for impaired women. So the aim of our VR project is to make a driving license more accessible for the impaired women. And we will design the system to practice driving experience, and the system will simulate traffic situations. Therefore, it must be VR technologies. After doing interviews, most of the impaired women want to travel by themselves, and impaired women are stigmatized as a bad driver and being incapable of driving. And Thai people think that a driving car is too dangerous for impaired women. And there are garages that modify a car that fit their conditions, but there is no driving school for teaching them with their car. So we decided that in our project, we will design a driving interface for VR that fit their conditions that they need, and VR will enhance the ability of impaired women to travel by themselves. And we cooperate with two organizations. And the first is a World Collisions company. This is a tech company that develop AI, and they hide impaired person, and we interview with those persons in this company. And the second organization is Advanced Driving School Bangkok, and we did focus group discussion with these two organizations. After finish focus group, we got this 4 lessons of driving simulator. The first lesson is traffic rules. The objectives are high-end coordinations and learning traffic rules. So they ask for tasks for these reasons: traffic lights, traffic sign, line and lane, and crosswalk. And the second lesson is draw the wheels. Objectives are hand-eye coordinations and accurate draw the wheel, and to left to right, 90-degree turn, U-turn, and roundabout. The lesson 3, rear wheel mirror. Objectives are hand-eye coordinations, analysis, and decisions making, such as give way to ambulance, switch the lane, and stop for pedestrians, stop for motorcycles. And the last lesson is 6 hazard situations. Objective of these reasons are situations experience and decisions making. We collect the 6 hazard situations that cause accident, such as dangerous lane changings, driving too close to leading vehicle, illegal overtaking, for helping them to making decisions when they drive in the real traffic. And next, we will talk about the design.
Okay, my name is Mores Prashyaprit from Faculty of ICT, Mahidol University, and we are researcher in this project. I'm going to talk about the main concepts of our simulator. To provide immersive and realistic driving experience, we will use VR as a central technology for our simulator. VR would make the user feel present in a virtual car and the driving scenario that will be depicted in realistic computer-generated 3D graphics. Immersion and realism would lead to emotional arousal, such as excitement and fear, which was found to improve memorization. Prior work in neuroscience and psychology showed that the intense emotion induced by an experience increased memory retention. With negative emotions such as fear was found to be especially effective. Stress hormone was found to enhance memory. Our training scenarios will employ vivid depictions of emotionally intense events, representing the negative consequences of improper or unlawful driving behavior to promote retention of safe driving knowledge. The next 2 videos from my prior work on driving simulator illustrate this key design idea. Okay. Oops. Okay. Okay, let me explain the video a bit first. Okay, here the user is. Okay, I'm sorry. Okay. Yeah, here the user is supposed to turn left and then drive in circle before going right to reach the target location indicated by the arrow. However, the user in the video take a shortcut by turning right immediately. Okay, you can see the what happens next. Okay, this bad driving behavior triggers an AI driver to accelerate and hit the user from the right side. This is the mechanism to convey a negative consequence to the user. As another as another example, the user is instructed to safely drive while following the waypoints indicated by the blue arrows. Okay, and the user in the video ignore this safety guideline by driving too fast. Okay, and see what happened next. Okay, yeah, this bad behavior triggers software to disable control of the car, simulating loss of control, leading to the crash. Okay, again, conveying a negative consequence to the user. Main techniques that will be used in our simulator. Correct judgment of distances is crucial for safe driving. Our simulator will generate perspectively correct graphics for both the left and right eyes to provide proper stereopsis cues to the user for enhanced depth perception and training. A high-end VR head-mounted display will be employed to provide highly detailed graphics, large field of view, and full field of regard. The user viewpoint will be tracked so that the user can look around 360 degrees inside the virtual environment. This is especially useful, for example, when the user wants to look at a side mirror or want to look back while performing reverse driving like this. Okay. The user real hands will be tracked by a VR tracker to support natural hand interaction with the virtual cockpit. Realistic sense of touch and relevant forces are important for training in physical driving skills. Our simulator will employ a physical cockpit registered with the virtual cockpit in order to provide passive haptics. For example, the feeling of touch and the weight when holding the virtual steering wheel and the feeling of stepping on a virtual pedal. In addition, a force-enabled steering wheel will be used to provide active haptics, such as vibration during impact or crash when driving on a bumpy road and other relevant forces when driving the car. Budget permitted, a motion platform could be used to provide proper proprioception, that is, the perception of our body movement when the car moves. Physically accurate car behavior is necessary for appropriate training experience. Our simulator will incorporate possible physics simulation. We will include autonomous drivers with AI and procedurally generated behavior to support non-repetitive driving situations, meaning that each time the user trains, the other cars on the road will behave differently than that in the previous training sessions. The AI behavior also will be used to trigger negative consequences of bad driving. Okay, here's another example. Okay, here the user is supposed to wait at the junction, then check the left side to make sure that it's safe before turning right and drive to the target location. However, the user in this video drive to the target location without waiting for safety. Okay, and look at what happened. Okay, this trigger an AI driver to accelerate and hit the user from the left side. again conveying a negative consequence to the user. The general scenario design will follow this pattern. After selecting a scenario, the user will be presented with the training objective, okay, such as to obey the traffic light. Afterward, the user start the driving practice. Okay, bad driving behavior will trigger negative consequence, okay, leading to restart of the training scenario. If the training objective is met, then the user will be presented with the conclusion screen, telling how well the user performs. We will use Unity game engine, which is one of the most widely used game engines with large developer community and excellent support of VR devices. When possible, we will use available tools and data to speed up the development process and to focus on the training logic. There's a free and beautiful 3D virtual city that could be used for driving practice in the project, okay, like shown here. Possible vehicle dynamics could be incorporated by using physics engine, such as ED physics engine. We will use the OpenXR standard for interfacing with VR devices so that our simulator won't be tied to a particular VR device. And finally, we will modify the physical cockpit to support impaired users by adding a hand control for brake and acceleration, like in the picture. And that is for my design overview.
Thank you, Ajahn Morris. I have something to add about our project. First, the impaired person that we interview and we collect data and we receive a comment from them is that they are impaired person who can live in daily routine, but they need some means, or they can drive. Some of them can drive and some of them want to drive. But in our situation in Thailand, having driving license, we also permit for the impaired person. But to train how to drive, there is a difficulty. Like we have to modify the car. And many of impaired person that we collect data, they comment about when they bought a car, they have to pay extra for modify their car. And before they have a license, they have to drive their car perfectly before going to test at the DLT, at the Department of Transportation. So that is the difficulty. And we cooperate, and we interview the driving school, and they are really interested in our system. They say that if we can do it, we can do this lesson, it will be benefit for both of the impaired person who have a demand to drive a car. The school can use this system as a test before going to drive in real car, because driving in a training car of the driving school, they have 2 sets of brake pedals, or some school can have another steering wheel to assist the teacher to assist the driver or driving student in the emergency situation. So when impaired person going to driving school, that is the big difficulty, because they have to modify the car and no training car at the school right now. Some of driving school, the school that where we cooperate, they have a program for the deaf. The deaf can drive a training car at the school, and they have a sign language translator to talk with a student and driving teacher. But in our project, we focus on movement impaired person. So the system of VR we can use as a practice or they can try to drive before they buy a car, or they can know how to control the modified car before going to real car and before paying for their car or the cost of modification. So this is the interest of our project. Thank you.